I'm covering 2-1 today, which is solving linear equations and inequalities. So we're going to solve linear equations using a variety of methods, and then solve linear inequalities using both algebra and number lines. And hopefully most of this is review. But solving equations is key to doing well the rest of the year. So equation is just a mathematical statement with an equal sign, which is why you have the EQA in equation. So different from an expression that has a variable but no equal sign, and an inequality that has an inequality sign. Solution set of an equation is the value or values of the variable that make the equation true. So sometimes you'll have one value, sometimes you'll have infinite values, sometimes you'll have zero values. All right, linear equation of one variable can be written in the form ax equal b, where a and b are constants and a is not equal to 0. So example, here's one, 2x minus 5 equals 0.1x plus 2. Notice there's only one variable, there's no y. There's just an x without an exponent. Here, nonlinear, there's an x, but it's an exponent, so this is not a linear equation. Properties of equality, we had these last year. I'm not going to really ask you specifically about these properties, you just need to know them to use them to solve equations. So addition property says if you have an equation that's true and you add the same number to both sides of the equation, then you haven't changed the fact that it's true. The equation will still be true. Subtraction is similar. We have an equation that's true, we subtract the same number from both sides, and we get an equation that is still true. Multiplication property of equality, equation that's true, multiply both sides of the equation by the same number, and the equality is still true. And then lastly, division property, which I somehow is not here, but if you divide a true equation by the same number on both sides, then you have an equation that's still true. So this would be the examples. All right, so we're going to use those to solve equations. You've been doing it for a couple years now at least. So let's look at some examples. Solve the equation -3 times 5 minus 4r equals -9. You can do this multiple ways. Some people would choose to divide out the -3 on both sides. In this example from the book, they use the distributed property to distribute the -3. Just be careful, you're multiplying a -3 by a -4 essentially. So this is going to be a positive 12. Then you add your 15 and divide by 6 to solve for r. And you can always check by plugging this back into the original equation and making sure what you get is correct. All right, next one, 3k minus 14k plus 25 equals 2 minus 6k minus 12. Just be careful. I see a lot of times in geometry, students want to subtract 3k because you're so used to doing the opposite operation to move things across the equal sign. Remember, this is on the same side. These two expressions are on the same side of the equation. If the expressions are on the same side of the equation, you don't have to do the opposite operation. You just combine your like terms. So you're going to have a 3k minus 14k here to get a -11k, and here you can combine your 2 and -12. Those are like terms on the same side of the equation to get a -10. And now you're just going to solve for the variable. They add 11k and add 10. Solve for k by dividing out your 5 to get k equals 7. All right, one for you to solve. You already saw the answer, so hopefully you know how to do this one on your own. An equation that's true for all values of a variable is an identity. And you probably are trying to figure out how that happens, and I'm going to give you an example. An equation that has no solutions is a contradiction. So these are two terms we're going to use throughout the year. So if basically there's an infinite number of solutions, that's an identity. If there are no solutions, it's a contradiction. So let's look at examples. Here's my two examples. Solve 3v minus 9 minus 4v equals negative 5 plus v, and then solve 2 times x minus 6 equals negative 5x minus 12 plus 7x. All right, so the first thing they did over here, let's look at one at a time. Distribute the negative sign, don't forget to do that. Then they add the v to both sides, and look what happens. We end up with just negative 9 equals negative 5. Negative 9 is never equal to negative 5, so that means there's no value of v that is going to make this equation true, which means it's a contradiction. The solution then is the empty set, which we talked about in Chapter 1. This one, we distribute our 2, we combine our like terms, so we get 2x minus 12 equals 2x minus 12. Subtract our 2x from both sides and you get negative 12 minus negative 12. That is always true. In other words, it doesn't matter what value you plug into for x, this equation is going to be true. This is an identity. So what is the solution? All real numbers, which I write like this, they have this fancy R. So the solution to a contradiction is the null set or the empty set. The solution to an identity is the set of all real numbers. So on a test, you should make sure that if I ask for a solution, you give me these, not just tell me that they're contradiction or identities. All right, an inequality is a statement that compares two expressions using the symbols less than, or equal, greater than, or equal. So it doesn't have an equal sign, it has one of these inequality symbols. And remember, if you multiply or divide an inequality by a negative number, you have to change the direction of the inequality sign. So here's an example, negative 4x is greater than 8. We're going to divide by a negative 4. Because we're dividing by a negative number, we have to change the direction of the sign. So it ends up being x is less than negative 2. And again, you can check it. If I plug negative 2 in there, I'm going to get a positive 8. So it has to, which is not greater than 8, but negative 3 is going to be positive 12, which is. So you can see that changing the direction is what makes the solution correct. All right, solve and graph 8a minus 2 is greater than or equal to 13a plus 8. So first thing we want to do is solve the statement just like you would if this were an equal sign. The only difference is this part where you might have to change the direction of this. So first thing they did is subtract a 13a from both sides. Now we're going to add a positive 2 to both sides. And at this point we're going to have to divide by a negative 5 to solve for a. That means we're going to change the direction, which is done here. And so my solution becomes a is less than or equal to negative 2. And we've practiced graphing inequalities. So the equal sign means we have a solid circle. So what does this look like? Here's our negative 2, here's our solid circle, and it goes infinitely in this direction. So make sure you have an arrow on the end of your shaded area. All right, here is one for you to try. Solve it algebraically and graph it. And that concludes this lesson. Pretty straightforward. So your homework is here, and bring any questions to class.